Number 11b, the roots of the equation 2x squared plus 3x minus 4 is equals to 0 are alpha and beta. Without solving the equation, find the values of Roman number 1, alpha squared plus beta squared, Roman number 2, alpha plus 1 in brackets into beta plus 1, Roman 3, beta over alpha plus alpha over beta, Roman number 4, 1 over alpha plus 1 all over beta. So in such a case, if we are to find the values without solving the equation, we take the equation that you have been given, 2x squared plus 3x then minus 4 is equals to 0. So what you do for this case, we need to make the coefficient of x squared to be 1. So we can achieve that by dividing all through by 2, by 2, by 2. So we will have x squared, because these two cancels, 1, 1, and plus 3 all over 2x, then minus 2 is equals to 0. So we have achieved, and the coefficient of x squared is now 1. So the concept we need to understand is that if we are given such an equation and we have been told that the roots are alpha and beta, that would mean the sum of the two roots, that is alpha plus beta, is equivalent to negative b, where this b is the coefficient of the middle term. So for this case, we'll say alpha plus beta is equals to negative of our coefficient of x, after making x squared to be 1, is equals to negative 3 all over 2. So the sum of the roots is equivalent to this, and the product of the roots is equivalent to c. Take note that the sum of the roots is negative b, and the product of the root is just c. If it is positive, you take it the way it is. If it's negative, so for this case, our product will be equals to negative 2. So if here we had minus 3 all over 2, then it would be negative of negative 3 over 2, then it will be positive. But if it is positive, then you make it negative. Remember, here it is negative b. So we have the sum and we have the product. So if you ask to find the value of alpha squared plus beta squared. So to be able to find the value of this, the starting point, you should recall that if I have alpha plus beta squared and I'm expected to expand, then using quadratic identities, it will be, you can expand the long way, but I'm using quadratic identities. The first term alpha squared, then plus 2 times the first term times the second term, that is 2 alpha beta, then plus the square of the second term. So I will have alpha squared plus 2 alpha beta plus beta squared is equals to alpha plus beta squared. So this one you can even expand using the long way, whereby you have alpha plus beta times alpha plus beta, you'll still get the same thing. So if alpha plus beta squared is equivalent to this, what would happen if I take this one across the equal sign? If I take that one across the equal sign, then I'll have alpha plus beta squared, then minus 2 alpha beta. On this side, I will be left with alpha squared plus beta squared. So see, what do we have here? Alpha squared plus beta squared. What do I have here? Alpha squared plus beta squared. So that means if you want to find the value of alpha squared plus beta squared, what you simply do, take alpha plus beta squared. Remember, that is the sum I'm talking about. Take the sum squared, then minus 2 times the product. You see the product? Alpha beta. So looking at this question, we had already read out the sum. Our sum is negative 3 all over 2. So we'll just say here alpha plus beta, that is negative 3 all over 2 squared. Alpha plus beta squared is here. Then minus 2 into the product. We had already said it's here. Product is negative 2. Then should be equal to alpha squared plus beta squared. So your work here should be to square negative 3 all over 2 squared, that is 9 all over 4. Then negative 2 times negative 2, that is plus 4. That should give you alpha squared plus beta squared. Now when you add these two, you'll be able to get that alpha squared plus beta squared is equals to 6 whole number and 1 all over 4. So that is how we do Roman number 1. So let's move on to Roman number 2. Roman number 2. Roman number 2 is alpha plus 1 multiplied by beta plus 1. So to do that, alpha plus 1, beta plus 1, the first thing, this is Roman number 2, the first thing we expand. So we take alpha into beta plus 1, then plus 1 into beta plus 1. I'm just taking this one times this, again times this, 1 times b, again 1 times 1. So it's the same as writing it this way. So alpha times beta get alpha beta, alpha times 1 we get plus alpha, 1 times beta we get plus beta, 1 times 1 we get plus 1. So this can be written as alpha beta, you can see that that is the product, then plus the sum of this, alpha plus beta, then plus 1. So to be able to evaluate this one, after expanding, we are realizing that we take the product, which was negative 2, then plus the sum, and our sum was negative 3 all over 2, negative 3 all over 2, then plus 1. You realize that here we have plus and minus, so the negative will be stronger, so we'll have minus 2, minus 3 all over 2, then plus 1. When you work out this part, we get negative 2.5. So if you have decimals, then it will be negative 2.5. Then the next part, that is Roman number 3. We have alpha. We are working it out from here. We have Roman 3 beta all over alpha plus alpha all over beta. So in such a case, you now combine them as a single fraction. So what we will do, we'll say the LCM is alpha beta. So alpha beta divided by alpha, we remain with beta. Then beta times beta, we have beta squared. Then alpha beta divided by beta, it's beta that would cancel, we'll be left with alpha. Alpha times alpha, we have alpha squared. So you will realize that what we are obtaining here is beta squared plus alpha squared all over alpha beta. But I want you to look at that numerator and recall Roman number 1. Roman number 1, we said alpha squared plus beta squared. When we simplify, alpha squared plus beta squared is equivalent to this. Is equivalent to alpha plus beta squared, then minus 2 alpha beta. So I've replaced the numerator with this all over alpha beta because we had expanded this in Roman number 1 and we got this. So you just go ahead and substitute the values. Alpha plus beta squared, we had it up here as negative alpha plus beta squared. Alpha plus beta is negative 3 all over 2. So we say squared, then minus 2 alpha beta, the product, we had got it here as negative 2, then all over alpha times beta again is negative 2. So what you do, you now go ahead and work out. This is 9 all over 4, then plus 4 all over negative 2. 9 all over 4 plus 4, that gives you 6 whole number and 1 all over 4, then 1 over 4, then we divide by negative 2. So that now when you divide by negative 2, is the same as 6 times 4 is 24, is the same as 25 all over 4 times negative 1 all over 2, which would give you negative 25 all over 8. That when you simplify, you get negative 3 whole number and 1 all over 8. So we are done with Roman 3. Then finally, we move to Roman number 4. Roman number 4. Roman 4, where we have 1 over alpha plus 1 over beta. And in this case, again, we put them together by LCM. So we have alpha beta. Alpha beta divided by alpha, alpha will cancel, so beta times 1, we have beta. Then alpha beta divided by beta, beta will cancel, we will remain with alpha. Alpha times 1, we have alpha. So when we combine, we get beta plus alpha all over alpha times beta. Remember, we had said the sum was negative 3 all over 2, and the product was negative 2. So you simply put them like that, then the negative will cancel. So have 3 all over 2, then divide by 2, which is the same as 3 all over 2 times 1 all over 2. Then here the answer will be 3 all over 4. So this